In this video, we're going to verify using calculus that the volume of a right circular cone, so here's a cone with radius r and height h, the volume of a cone like this is 1/3 pi r squared h. You may have seen this formula before, probably never derived it. We're actually going to use calculus, namely the disk method, to derive this formula to see why this formula is true. So let's see how this cone is generated by rotating a triangular region. So I'm going to take a line segment here as point H, and in the y-axis I'm going to pick R, and this point right over here is HR. We're going to make a line segment from the origin to this point and then drop perpendicular down to the x-axis and rotate this triangular region about the x-axis so that 180 degrees rotation will end up over here in the fourth quadrant. We rotate it 360 degrees, we end up with this cone, and so the distance right here is its height, that's h, and this is a radius of the cone, that's r. So this is a right circular cone of height h and radius r. We're going to use this technique, the disk method, to see what the volume is. So let me draw this once again. And we have this line segment going from the point 0, 0 to the point HR. Let's find an equation of a line that contains these 2 points. The slope is change in y, so that's r minus 0 over change in x, which is h minus 0. That's just r divided by h. We're going to select one of the points on the line. The origin 0, 0 is on the line, so it's an easy point to work with. Y minus 0 is y, equals the slope r over h times x minus 0, which is just x. So we're going to now pick an x between 0 and h, any x, and keep track of this vertical piece of the area. As this rotates 360 degrees, it generates a disk that looks like that. And we can turn this disk sideways so that we can further examine it. Here's our disk. We want to find the volume of this disk as a function of x. The radius of this disk is this distance right over here, and that happens to be the y coordinate of this point, so let's just call it y. And we're going to give it a little bit of thickness. We call it dx, so the volume of this piece is pi times radius squared, that's y squared, times dx. Now let's express y as a function of x. We know that y equals r over h x, so this is equal to pi times r squared over h squared times x squared dx. That's just one tiny slice of the volume of our cone, and what the integral does, it sums them all up and gives us the exact value. So the integral is going to be the integral from 0 to h, because that's where all the x values are, between 0 and h, and it's pi times r squared over h squared times x squared. Remember that both r and h are constants, so this is pi r squared over h squared, and the integral of x squared is 1/3 x cubed, evaluated from 0 to h. And this is equal to pi r squared over h squared times 1/3 h cubed. Of course, plugging 0 in for x will give us 0. H cubed over h squared is h, and we end up with a final answer of 1/3 pi r squared h, and that's the formula for the volume of a right circular cone with